Hiya! So in this video, we're going to look at an example of the normal distribution. So technically, we've been looking at normal distributions for a while, but this time I want to look at a normal distribution without having looked at a binomial distribution to kind of see how this kind of works and where things kind of come from. So in this case, let's kind of see what information we have. So suppose that we take repeated measurements of the weight of a standard kilogram. So for people who don't know, the standard kilogram, there's actually a block, I think it's technically in France, it's somewhere in Europe, that measures a kilogram. So anytime anything is measured as a kilogram, it's compared with this block to make sure that it's actually a kilogram. So there's an actual physical thing that it's measured with. Now the problem is over time, even though it's in a special case and everything, things erode, right? There's space, things hit it, like molecules, air, etc. So it does eventually start losing some of its weight. And so we know, so it slowly decreases mass. And we know that the weight is a normal distribution. So here I'm saying the weight is a normal distribution with expected value of 1 kilogram. And standard deviation of 20 micrograms. So something really, really small. And the question we're asking is what approximate, so here I'm saying approximate because we will always use phi, proportion of measurements are correct to within 10 micrograms. So let's first write out some things. So first let x be the weight of the rock, be the weight of the rock. And what we're going to do is we're going to look at a microgram. We're going to convert everything into micrograms. So 1 kilogram is roughly equal to 10 to the 9 micrograms. So 10, so 1 with 9 zeros after it. So basically what we know is the expected value of x, right? We're told this is 1 kilogram. So this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know the standard deviation is 20. So standard deviation of x is 20. So what this actually tells me is the variance is also equal to 20 squared, right? So 20 squared is equal to 400. I'm not sure if that's going to help, but we'll see. And the question is basically asking, well, what is the probability that our measurements are within 10 micrograms? So in other words, I want to know when we have, I guess the lower part would be minus 10. So 999, 999, 990. So this is minus 10. Less than or equal to x, less than or equal to, actually this should not be there. There we go. 2, 3, 4, 5, 6, 7, 8, 9. And so this on the right hand side is plus 10. So we want to see what the range is for plus or minus 10. All right, cool. So what is this? Well, let's kind of, can I copy? Do I have room down here? I have some room. So we'll kind of remember all of this in mind. And what we're going to do is we're going to convert this into a standard deviation. So the standard we're going to look at it from the standard normal perspective because those 5 values only work for the standard normal curve. So we have to look at standard normal distribution first. So what we need to do is convert x to standard normal. And what this meant was that we need to look at z, which is equal to x minus mu divided by sigma. And these things we already know, right? So z is equal to x minus, the expected value is 1, I guess, trillion over 20. So that's basically what we're going to plug in. So what we have is p is, so I need to convert this. So if I do x, I need to first subtract 1 million. So 999, 999, 990 minus 1 billion, sorry. And I have to do the, and then divide by 20, and I have to do this with all of them, right? So 3, 4, 5, 6, 7, 8, 9 divided by 20, and I have to do it with this last one. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided, minus 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 20. And the good thing is most of these things disappear. So here we would just have P is, this top part is just minus 10, right? Divided by 20. This middle part is now our Z. And this right-hand side is just 10 over 20. And this we should already be very familiar with how to do. This is just our, so approximately, this is our B and our A, right? B, sorry, this is our A, this is our B. No, this was right. It was the other way around. B and A. So we ended up having phi of B minus phi of A. So phi of 1/2 minus phi of 1/2 minus 1/2, because we have this negative here. And if you plug this in, you should get, as long as I did not screw up my stuff, you should get roughly 38.29%. And so that's basically how often, what the chances are that we'll get a measurement between that kind of range. So we'll stop here for now. And in the next video, we're going to expand this a little, and we're going to look at an arbitrary continuous distribution. What happens when we're not looking at, so kind of like how we did in the discrete, we said, okay, well, how do we figure out a discrete distribution without any particular thing? We're going to look at a similar thing through examples for an arbitrary continuous distribution in the next video. So I will see you then. See you soon.